Welcome back. Today's problems I want to do is to get you a little bit one last step of complexity with forces that cause acceleration or that can be solving problems. And so I'm gonna do one last class of kinds of force problems with you, so that you get used to those common angle forces. And I've tried to limit it just to a couple. I didn't go through all of them, but I do want you to get a little bit of experience in how to calculate some of these forces that we had. So you've still got those units from your notes. Here I can show what those look like. Let's bring that one up. Physical science. So here's where we left off with those. All these different kinds of forces. The biggest ones in here are in this area of force of friction and weight. The spring force, buoyant force. I mean, those are, you're going to run into those, but they're quite as tricky as these. So I'm going to specialize by looking at those today. And so let's give that a try. Today's worksheet is going to be common force calculations, and let's just see how we work these through. The first thing you're going to say is a carton of milk is 2 kilograms. What does it weigh? Weigh is a common force. Weight is a force of attraction by gravity. So that's going to be equal to whatever the mass is times gravity. And so you're going to take your 2 kilograms there, and you're going to take that times 9.8 per second squared, and this ends up becoming 19.6 newtons. Okay, so you take the mass times the gravitational constant of 9.8, and that'll give you the weight of that carton of milk. The next one is, what's the weight of an object that accelerates from 1.6 meters per second from a 2 Newton force? So that's just rearranging this a little bit. This is the classic force equals mass times acceleration. Mass here is going to be the unknown. And so you know the force is 1.6 newtons. Sorry, that's 2 newtons. That's the last answer. 2 newtons. And that's going to be equal to your mass, which you don't know, and times the acceleration, 1.6 meters per second squared. Okay, and divide both sides by 1.6. I'm going to get mass is equal to, and I just have to look real quick, my answers are over here. The mass on this one ends up being 1.25 kilograms. Okay, that's when I take 2 divided by 1.6. Good. So those are some of those first ones that should be get us sort of back into that feeling for the answers. I'm going to move this up a little bit, and when I do so, I think I'll have to erase these other ones. We've done 1 and 2. Let's take a look at 3. Okay, these ones, now that I start to get to some problems that you've got an object, I'm going to start to draw them. And it's called a free body diagram. So it don't have to ever look great, but I'm going to draw this fish hanging from a scale inside of a elevator here, and this mass of this fish is 10 kilograms. The forces that are acting on that fish are what is important to draw. The fish has a tension on here that's going up to the scale, and that's what, of course, the scale is going to read. The fish has a weight, which is equal to the mass times gravity, so it's a 10 kilogram fish. 10 kilogram fish weighs 998 newtons, sorry. So the weight of that fish is 98, and that fish is also being accelerated. So here's your drawing, and I'm going to have to put in then what's happening to this. So the forces for that fish have to be the mass times the acceleration. Now, it really is that total of all the forces acting, and since there are 2 forces on here, one is the tension that's going to be registered on the scale. I'm going to actually have 2 forces that I'm going to add together. The tension on the force, the scale goes up, the weight goes down, so they're actually subtracting each other. Anything that goes in opposite directions is subtracting. So I've got tension minus the weight, that's equal to mass times the acceleration of that whole system. Tension is what is going to be read here by the scale. The weight I've already calculated is 98. And that's going to equal the mass that is now accelerating, 10 kilogram mass. And that's going to take it times the acceleration, which is 4 meters per second squared. 2. All right. So the tension is just going to be all these added up. When I work that through for the fish, it's going to be tension. This is minus 98 because of the direction of that. When we work these all out, it's going to be 40 on this plus 98, so that's going to come out to 138. Okay, so the weight on the scale up here is more than what the fish would weigh, which is 98, because it's also accelerating. So that is in addition. The tension is going to come out to be 138 newtons. So that's a good start in terms of these forces. I'm going to break these up into segments. So that's that first segment 1 through 3.